Salam Totanoding and all my fellow classmates. My name is Livingston with matrix number 212727. In this video presentations, I'm going to talk about the concept of dimensional analysis under the course of fluid mechanics. Before I start, let me go through about what I have to talk about in this video presentations. It covers about dimensions of various quantities, dimensional analysis, uses of dimensional analysis, examples, and its advantages. First, what is dimensions? Dimensions is actually defined as a technique or method which the physical quantities can be expressed in terms of combinations of basic quantities. Or in other words, it is a physical property which describes a way that any physical quantity is related to fundamental physical quantities. And it can actually be written as a standard form, that is, the physical quantities are a symbol in a square bracket. The following tables shows 6 common base quantities and along with the respective dimensions. Basically, the base quantities are defined as physical quantities that cannot be defined in terms of other physical quantities. To determine the dimensions of base quantity, we first have to put the square brackets on the base quantity, on the basic quantities, so as to make it become a symbol of dimensions. For example, to determine the dimensions of time, first you need to put the square bracket of it, or you put the square bracket of the time t symbol, and the final answer for that will be the capital T, that is the dimensions for that particular basic quantities. And yeah, its unit is second. Let's have a recap of the dimensions. What is the dimensions of mass? To answer this question, you first have to start with a square bracket along with the physical quantities. You can see the second step, you can write in this way, that is to insert put the square bracket along with a symbol of the physical quantities. And from the table, we know that the dimensions of mass is capital N. And this is our final result for this question. Now let's come to this main part of the video presentation, that is to explain about the dimensional analysis. Actually, dimensions can be treated as algebraic quantities through the procedure called dimensional analysis. So what exactly is dimensional analysis? It is defined as an analysis using the fact that physical quantities added to or equated with each other must be expressed in terms of the same fundamental quantities such as mass, length, or time for inference to be made about the relations between them. The diagram shows several uses of dimensional analysis. Scientists use dimensional analysis in order to determine two things, that is to determine the unit of physical quantities as well as whether or not a physical equation is dimensionally correct by using the principle of homogeneity. Lastly, it can also be used for the purpose of deriving or constructing a physical equation. Actually, there are a few notes that have to be taken into account when we are dealing with dimensional analysis. First, dimensions of dimensionless constant is always equals to 1. For example, the dimensions of 2 is 1. The dimensions of 3 is also equals to 1. To sum up, the dimensions of any numbers, well, no matter is whole numbers, integers, or rational numbers, it is always be equals to 1. In other words, and you can see that the next example will be the Reynolds numbers. The dimensions of this Reynolds number is always equals to 1 because of its dimensionless unit, which make it a number and hence equals to 1 for its dimension. The second things will be the dimensions cannot be added or subtracted, and the validity of an equations cannot be determined by dimension analysis, but through experiment. Let's have a look at a few more examples to have a better understanding about dimension analysis. Determine the dimensions and SI unit for density rho. To start or begin with this kind of questions, we first have to write down what is the formula for the physical quantities that which dimensions have to be determined. For example, to determine the dimensions of density, we first have to write the density formula, which is the mass divided by volume. Then we start with dimension analysis with taking the dimension of both sides of this equation, that is rho in square bracket equals to m in square bracket over v in square bracket. We know that volume is equals to length times width times height. Therefore, it can be written as L in square bracket times W in square bracket times H in square bracket. Now it's time for us to review the dimensions of each of the base quantities. The M becomes the capital N. The L, W, and H becomes capital L. With a little help of the properties of indices, we comes up that the dimensions of the density turns out to be capital M times capital L power of -3. From here, we can determine the unit of density, that is kilograms per meter cube. The second example will be determining whether the formula given is homogeneous. The formula given is in pounds, that Ft equals to mv minus mu, and we are required to determine whether the formula is homogeneous or not. First, we have to take the dimensions on both sides of these equations. The right-hand side, the dimensions is found to be mlt -1. And then the dimensions of the right-hand side of both terms, that is mv minus mu, is the same as the left-hand side, mlt -1. Then we can conclude that since the dimensions of the left-hand side is equal to the dimensions of the right-hand side, therefore the formula is homogeneous. The last example is quite complicated. A sphere of radius r and density rho s falls in liquid of density rho f. It achieves a terminal velocity v given by the following expression, where k is a constant with dimensions of m, l -1, t -1, and g is the acceleration due to gravity. Determine whether the equation is homogeneous. Again, to determine the dimensions, to determine whether the equation is homogeneous, we have to first determine the dimensions of both sides of the equation. On the right-hand side, the dimensions is found to be Lt -1. And although the right-hand side of this equation is quite complicated, but as long as we didn't make any careless mistake during the dimension analysis, we will get Lt -1, which is same as the right-hand side, the left-hand side. After that, we can conclude that since the dimensions of the left-hand side is equal to the right-hand side, therefore the equation is again homogeneous. The last part of this video presentation is about the advantages of dimension analysis. It is quite similar to the uses, but this time it gives you more information about its benefits. Actually, there are about 5 advantages of dimension analysis, as a preliminary test for the correctness of the given equations, converts from one unit to another, and it helps or reduce the number of the experimental methods. Furthermore, it also helps to derive the relationship between physical quantities and also determine the dimensions of constant or unknown physical quantities. And that's all about my presentations about concept of dimension analysis. Thank you for listening. Hope you gain knowledge or information from my presentations. Thank you.